Real numbers. Real numbers are given this symbol, a double-barred R. It's the collective name for all the numbers we have met so far in this chapter. A natural number is an integer, and we've seen that n is a subset of z. The natural numbers are a subset of the integers. So we've seen this picture before. An integer is a rational number. We've seen that we can write all whole numbers as fractions. So the set Q goes all the way around the outside. Rational and irrational numbers form the real numbers. So if we combine the sets rational and irrational, we get the real numbers. So the real numbers fit around the outside like this, and the outside region here contains the irrational numbers, i.e. those that are not in the set Q. Prove by contradiction that for every non-zero real number there exists a unique reciprocal. So let's have A belonging to reals, and A has to be non-zero, and we're assuming that that has no reciprocal. But 1 over A must belong to the reals as well, and A times 1 over A would be equal to 1, and there we have a contradiction. Disprove each of the following by giving a counterexample. If A and B are rational, then A to the power B is rational. We'll consider 2 to the power a half, which we know is the square root of 2. The square root of 2 is an irrational number. If A and B are irrational, then AB is irrational. Root 2 is irrational, and so is root 8. But that's root 2 times 8, which is root 16, which is 4, which is a rational number. Consider x squared plus x plus c is 0. For what values of c will there be integer solutions? Let's solve this quadratic using the formula. So x would be -1 plus or minus the square root of 1 squared take away 4 times 1 times c, all divided by 2. So that would be -1 plus or minus the square root of 1 minus 4c divided by 2. Now, we want this to give us integer solutions. That means, since this is a -1 here, that root 1 minus 4c must give an odd integer. Can't be an even one, because when we're adding or subtracting 1 and dividing by 2, so it has to be an odd one. So what we can say is that 1 take away 4c must be equal to an odd number squared. So 4c would be equal to 1 take away 2m plus 1 all squared. So 4c is equal to 1 take away 4m squared, take away 4m, take away 1. So 4c is equal to -4 m squared plus m, and therefore c is equal to m squared plus m, where m is an integer, and that should work. Any c of this form should give us integer solutions. We're now in a position to do exercise 7.06 on page 270.